first? It's up to you. You want to look at the word problems right away? Do you want to do the? It looks like there's conics. Number one. Okay. All right. So this one.
This is a circle. This is like pretty easy.
Okay. Okay. Let me see what the element's going to ask. Okay. Find the center is fine, and the radius. The radius may be more challenging. Let me see graph. Okay. Do you want to look? Do I want to do it? What do you want to do in the next one? Number 2.
Is it?
Let's do number 2 because number 2 will have number 1 in it. Do you want to do it because there's more, manipulation to do?
This one, do we need to complete the squares, right?
Yeah, that's right. But then it will turn into number 1. Therefore, it will cover number 1 at the same time. Shall we do it? Let's do number 2. You can see the whiteboard, okay?
Yeah.
Okay, let's do number 2. So, yeah, so we want, let me see, it is a circle again, I'm pretty sure. Yeah, because it's saying, yeah, this number 1, number 2 has the word radius in it. Automatically, it's a circle. But you're supposed to know that. One more time, okay, how? If the coefficient of the x and y squared, it doesn't matter where it's arranged, where they are, okay, in the equation, are the same, therefore it's automatically a circle. So here, let me put the x with the x, leave a little gap here, and the y with the y. So the y squared minus 4y, and then add the 1 over. Is that okay? Let's do that right now. Add the 1 over. Double check my math, okay? Copying. Okay, take the 4 divided by 2 and then square it. So it becomes 2 squared. Write all the steps because you'll need this number here. So you don't have to actually try to think too much. So it's 4. You add 4 to both sides, but put the 4 right behind the x's. Plus 4 over here. And then do the same thing for the y. Take the coefficient of the y. Not the y squared, the y. Let me put it right below it. Negative 4 divided by 2, then square it. Equals negative 2. Square it. I'll give you another 4. So add 4 to both sides. Okay. And then factor the trinomial. Okay, wait. There's a plus here. So see, there's a plus here. It's got to be plus here. Okay. Factor the x trinomial and the y trinomials. Okay. So if you factor, it's going to be this number, the one before you square it, after it's reduced or simplified. So it'll be plus 2 squared plus the y minus 2 squared equals, what is that? 9. No, yeah, so they made this to be nice. So, okay, that's fine.
And the radius would be 3, right?
Yes, the radius would be 3. Is that okay? Like, yeah, just the r coming from here, it's going to be root 9 equals 3. So you can show it like that. So it's 3. R equals 3. What is the next part? Center. Center is the opposite. HK. HK. Wait, let me write the center. The word CN. I recommend you CN. Don't use C. So center is going to be negative 2 comma positive 2. H comma x H comma K or X. Yeah. Opposite here. X Y.
Wait, why is the center at negative 2, 4?
Not 4. Negative 2, 2. Sorry. HK. Is that okay? Opposite here, opposite there. They're trying to mess with you on that one. Careful, I'm not switching here. I'm not switching there. That's not it. Is it okay? X comma Y. Opposite, opposite. What else here? And then grab it by hand. Find the intercepts. Okay, if any. Okay, then write the equation. Then write an equation for the bottom half. Okay. Did you really want to mess with you, pushing your understanding here, right? Okay, grab my hand first, so we'll do it in that order. All right, fine. Negative 2 comma 2, 1 2 comma 1 2, negative 2 comma 2 right there. And then the radius of 3, just count it 1 2 3. So here, in there, in here, and up 3. Where's my lower one? 2, 2, 3. Okay. Something like this. It's just a sketch. Yeah, don't worry, yours not too round, circular. Okay, now you have to find the intercepts too, but wait, I'll do it in order. Find the intercepts. The second half is more fancier. You're gonna do that y-intercepts here. You got 2 y-intercepts, and you got 2 x-intercepts. Oh, actually, I'll bubble it right here, right here, right here. Okay, anyway, I don't know. I'll put a bold dots here, so you know what we're looking at. And the y-intercept, there are 2 y and 2 x-intercepts. How? How do we do it? Well, based on the algebra concept you've been doing, x, y. You remember, if you set x equal to 0, you're solving for y-intercept. If you set 0 for y, you solve for x-intercept. You remember that? So these are the intercept rule. Let me put it above here. Intercept right here. All right, let's do it. I recommend you do it from here. You want to use the HK form, the standard form. Are you ready? So let's do the x-intercept. Wait, it doesn't matter. It's the same amount of work. Which one do you want to do first? X-intercept? So you do x-intercept, you set...
Does not matter to me.
Okay, x-intercept, you're going to do y equal to 0. So let's substitute y equal to 0. I'll show all the work here. Equals 9. And solve for x. Clean it up, it becomes 4 equals 9. I know you can do it faster, but I'll show all the work here. Now, I don't recommend you actually FOIL, like expand x plus 2 times x plus 2. Don't do that, okay? Don't do that. Go ahead and just leave it in the factored form or the square form, perfect square form. Subtract both sides by 4. You get to recall, you get to show all the concept that you done in algebra, like square root property you're about to do here, or square rooting, the rule for square root principle, square root principle. I don't know. They call it different. Double check my math. Subtract both sides by 4, left with 5. And then you square root both sides. I don't do that. It's really plus or minus root of 5. And you drop x plus 2 here. Remember that? To get the base by itself, you square root the other side, plus or minus. Or you can think square root both sides, but then you have to do a plus or minus on the other side. And then subtract both sides by 2. And you're left with negative 2. Recommend you put it in the front, plus or minus 5. I believe you can just leave the answer like that unless your teacher wanted to be, x, what do you call it? The coordinate form. If you want to do coordinate form, you can do that too. But I'll still condense it. Here's the x-intercept. Okay, I'll put it right below here. X-intercept will look like this. But I think that's good enough. But I'll go ahead and make it in coordinate form.
Wait, does it matter if you put the rad 5 before, like the -2?
Yeah, it doesn't matter. You can put it in the back. Make sure it's not close inside the root. Now, I recommend you do exactly the way I have here because this is standard, like the way that they want it, or in the textbook, in the answer guide, your teacher has it this way. You put you do a plus, whatever you have in front of the plus or minus. You add or subtract both sides. Put it in the front of plus or minus. I know you can put it in the back, but it's not standard looking. It's up to you. Your teacher will accept it. Your teacher will know. But here it is, the x-intercept. You want me to summarize it in coordinate form? It will look like this. I'll still write in condensed form though. 1 plus 1 minus, comma 0. That's your x-intercept. Okay, y-intercept the same way. This time you set your x equal to 0. Then solve for y. Okay, so that's a 4. Subtract both sides by 4. That looks weird, but okay, I think you follow. It's y minus 2, okay, here. It looks, I don't know, that looks weird. Equals 5 again. And we could evaluate why that is. It looks right, but okay. So anyway, plus or minus root 5 on the other side. And you have y minus 2 plus 2 to both sides. I recommend you put it in the front of the plus or minus symbol. It's standard. So your y is going to be 2 plus or minus root 5. And you want to, in a coordinate form, you can. So it'll be 0, comma, 2 plus or minus root 5. Yeah, so there's your four x and y intercepts. Let me see the x-intercept. Yeah, one way negative and one positive. I'm just kind of checking it. Yeah, a root 5 is greater than 2. A little bit. Oh, but why is it? Wait, let me. Oh yeah, and then you subtract 2, and then you subtract 2 from it. So yeah, that's why it's going to be less than 1. Yeah, looks good. A little bit greater than, it looks good to me. Checking. Are you okay with that? Now you have to write the equation. Write an equation for the bottom half. Do you understand what that is? It's like if you cut this like in half this way, the bottom half is here. You know this? You okay?
Mm-hmm.
If you cut it in half.
Yeah.
So you know how that works, right? You have to solve for y in terms of x. Y from here in terms of x.
Yeah.
Okay, and then do you're gonna get plus and minus out of it, right? You can imagine that with x on the other side, and all you do is just cross out the plus. You want to see it? Let's do it. So bring it over here.
Yeah.
So let's do it. Solve for y in terms of x. Okay, I'm gonna skip. I'm not gonna copy the original. I'm gonna subtract both sides. So I'm gonna by the x term. So here I'm subtracting it over, so it'll be equals to 9 minus x plus 2 squared. You could do a negative if you want, but this is standard again. Also, don't worry too much about the arrangement. So I subtract both sides by x plus 2 squared, and then square root both sides. Again, you're gonna get a plus or minus in this side here, like this. Now, some of you guys will FOIL this and distribute the negative. I don't recommend it. Leave it like that. So this is it. Then add both sides.
And since it's
with
the bottom half, it's the negative one, right?
Yeah, but you still have to add the 2 over. But let's add the 2 over first and see. And then you could kind of look at which one you want to pick here. So, for example, it's going to be the minus one. It's the lower ones or smaller ones. How about that? Think of it as y values. Is that okay? Look, if you cut this in half, the y values are lower here. Get it? So lower y values got to be the minus one, like the 2 minus. See it? Is that okay? So here it is. You show all the work here, but then you kind of like extract the minus one. Your y values, the smaller y value is going to be the bottom half. The smaller y values of the circle, the x corresponding to all the x's in the domain. I'm surprised he doesn't ask what the domain and x in domain and range, right? Yeah, why not just do that? Yeah, I think that's it. Is that okay? That's done. Yeah, double check the math, but I'm sure it's all good. Okay, let's do the word problems here. Right back. All right. have a look here. A page with dimensions of this and that has a border of uniform width. I mean, I'll go by the picture, but I want to make sure that I see all the details here. Of uniform width x. Okay. So careful here, okay? They're saying from here to here, it's 8.5. From here to here, including the x in it, all the x's, the two x's from both sides. Yeah, I'm pretty sure that's what they're saying. The page, yeah. The margin, like the typical paper I used to write or print. Let me see. Surrounding the printed matter of the page, as shown in the figure. Develop a model that expresses the area A of the page as a function of the width x of the border. Now, I believe they want develop a model that expresses the area A of the printed part. So this is what they want. You agree? Is that okay? Do you understand it? So we'll do that.
Yeah.
Okay, we'll do that. So you're gonna do A of x. This is your objective. So I'll leave it. Okay, I guess we can just go at it right away. Because okay, how does it work? Well, I think you can see by looking at it. The area is going to be this times this, like length times width. You agree? Like that. But then you have to come up with the label for this side and this side. That's all. So what is it? Well, I should write sideways, but I have my let me see. I hope it doesn't disconnect. I have my connected. Okay, we'll write it sideways here. One second. Yeah, I won't. Yeah, I have it hooked up. I better not. It's magnetic again, but I have a better one. I don't know if I told you about it, right? Okay, let me see. Since this is 11 inches, okay, it means the inside here. Let's see. Do you want to tell me before I write it? How long is this right here? It has x in it. This is x long. This is x long. This is something you
11
what?
11 minus 2x.
Yes. You okay? Good job, dude. And this one, yeah, exactly. And this one is 8.5. I'll do decimal, dude. 8.5 minus 2x. Is that okay? Yeah. We're gonna do decimal, okay? Don't do fraction here. It's word problems, or you're more you're free to do more. You're free to write in decimal. Okay, so length times width. I don't know. It doesn't matter which one first. I'll do 8.5 minus 2x times 11 minus 2x. Now, I don't think you need to FOIL it. But let me think. Unless you need to use it. Develop as a function. Yeah, this is it. If you want to FOIL it, you can, but I'll leave it blank for a little space here to do that. But let me see. Is that done for A? Develop model of area A of printed. Yeah, that's done. If you want to FOIL it, you can, but let's wait for it just in case we don't have to. If not, your teacher should be fine. B, give the domain and range of A. Okay, now there's a concept here. Okay, let's do this. This is going to be important for calculus. It's pre-cal. It's important right now, especially calculus. They're going to come back again. This is going to come back again in calculus. But it's pre-cal. It's really pre-cal because you're starting it here. So how does it work? They were talking about the domains and range, the possible x's that you can actually use, and it won't be undefined. It won't be out of range. I mean, I don't want to use that word. And the range also. The range will be the a value. The domain will be the x value. Is that okay? One more time. This is like the y. The a of x is like the y. A of x is y. Therefore, y is, when you talk about range, it's associated to y. You remember that? Like the y range, and the x, right? So now let's do the domain first. So domain, it will be the x, and then the range. Now, how does it work? They're talking about for one function only, okay? So A, it says A. That means you only got one domain, but you got to pick one. How? How do you pick it? You got to pick the smaller one, and I'll explain why. And then how do you write it? You write it like this. You can write it different ways. And some people write it like this: greater than 0, but less. It's like this. If you do the work, you're gonna express your domain and range. Like the range will be the similar arrangement. It will be something like this: be less than, between two values, greater than 0, but less than some value here. And that value is what you're going to do here by solving. Some people use equal sign here. Let me do it like that. I'll put equal here. You know what? Let me do it greater than 0, because that's the proper way. Now, there's more debatable stuff here, okay? But what I mean is that let me solve it first. You know what? It will look like this, but let me just solve it first. I recommend you do it like this. Now, why would you do on the big one? I'll do that in a second. I'll explain it, and it will cause problems. That something's gonna not work. So let's solve this first. Negative 8.5 divide both sides by negative 2. It'll flip the arrow. That's why it works. That's why but you're gonna have to actually put a 0 here. But let me do this first. What is half of that? Half of 8 is 4. Half of 5 is 2.5. So it's 4.25. Check my math. Is that right? And then you got to put it together this way for the domain. Let me bring it in. So the domain will be between 0 and 4.25. Okay, now what about the bar stuff? Okay, here's the thing. If you put the bar, now this is I'll try to explain. Let me be neat here first. Now, what about, do I include 0? Do I include 4.5? So you cannot include 0 technically, because if you say 0, right? Let me see first. I'm sorry, I may be wrong here. If I put 0 here, that means you're going to get 8.5 fully. But that 8.5 is not in the area. Anyway, you can ask your teacher about it. Do I include the bar? Do I not include the bar? Okay, there's something about this, but I would say mathematically, you should not include them. Okay, because things does not make sense if you do. You no longer get the area that's less than inside the page. Get it? You cannot get that. But ask your teacher about that. But okay, now the range will do the same. But let me first talk about this. The domain will relate to the range. So we're gonna do that in a second. But what about this big? I'm sorry. What about the big one? Right? What about the big one? You might ask, why don't I do it the same for the big one? Let's have a look. Okay, if I do, whatever. Let me just do it. Like, let's just go ahead and do it the same way. But you don't have to copy this down. Okay, I'm gonna show it to you right now. 11 halves, 5.5. Flip the arrow. And then you can kind of like, hey, do the same. It'll be between 0 and 5.5, like this. Now you'll be thinking, hey, why can I use that as because here's the problem, right? If I put a number bigger than 4.25, like 5, right? It's between here, right? In this equation, okay, if I do that, what will happen? Let's see what happened. If I put 5 in here, you see, if I put 5 in right here, it'll be a negative 10. and I combine it with 8.5, it would be a negative number. It does not mix. It will not work. The error will be a negative. Do you see it?
Uh-huh.
Do you understand that? So you must remember to, when you find a domain of the problem that has like two sides like this, you will take the smaller one and then do the math like this. One more time, you take the bigger one and you test it. Let's say, hey, your domain can be between 0 and 5.5. No, that's not true, because if you use the 5, which is between 5.5, 0 and 5.5, and plug it back in here, you see like right there, and do the math, you'll get a negative area. There's no such thing. Is that okay? So therefore, you must remember, do you understand that? The math part? Louis, you okay? If I plug it in here right now, I'll get a negative 10. If I combine 8.5 minus 10, that's a negative number. The whole thing is negative. Area is not a negative number. Do you see that? Is that okay?
Yeah.
So therefore, remember to only use the smaller side and do the domain and solve for the domain. So it's going to be between 0 and 4.25. As far as the bar, that's ask your teacher about that. When you do it by hand, you should not have the bars, including the range. Now, in a computer, right, there's Alex, whatever, they similar problem, they actually have you bracket them. That means inclusive, but that's computer. It's computerized. So anyway, questionable thing. Okay, now let's go to the range. Are you following so far, Louis? So this is going to be your question mark here.
Yeah.
Ask your teacher, what do you want? Do you want the bar there? You don't want the bar. Yeah, the Alex system include the bars, which is technically, mathematically would be wrong, but it's computerized. There's similar problems. I'm not saying this one, okay? So ask your teacher about, do you want to put the bar? Do you want to put the bar? Okay, now the range. Simple. You're going to put the 0 into the area, the end values, right? The 0 and the 4.25 into the A and see what you got. So if I put 0 in here, I'm going to show you the work here. A of 0 here, and I'm going to do A of 4.25 here in the back here, between those two numbers. Do you understand why? Because you're limited between the x's between 0 and 4.25. Okay, so you're limited between there. Therefore, your range will be also depend on that, depend on the x. That's why they call it dependent variable, right? The y, the range is the y, the domain, your x. So your y depend on the x. So the x must be between 0 and 4.25. Therefore, you have to figure out, hey, what the y or the range, the a, or the area would generate between those two numbers. What are the values, max and min? So you put 0 in here. So basically it's going to be 11 times 8.5. Do you understand? Let me go ahead and use the calculator. 8.5 times 11. So the first value, the smallest value is 93.5. Again, the bar here, you can ask your teacher. If you put the bar here, you're going to put the bar here. Do you get it? You put the bar for the x, you're going to put the bar for the y.
Yeah.
So that's the minimum area. The maximum area, you put 4.25 in here. So I'm going to use the calculator again. Now again, you can FOIL this thing if you want. Okay, let me put it in the calculator. Let me bring it to the side here. Okay, nice. Check my math. 8.5 minus 2 times 4.25. Are you following all this? It's I hope your teacher went over it, but of course you want to see this again, like right now. 2.5. What's the parenthesis? Okay, I hope I put that in correctly. Look, as you can see, if you use the actual value, right? Okay, so it's actually flipped. So I'm not perfect. I don't remember everything, right? You got to flip this over. You're going to imagine, hey, the biggest number is 8. Anyway, you shouldn't actually be I should not be pointing the arrow here and here, you know, like right here and here. It's actually flipped the other way. Do you understand? The minimum value, and here's why you should not include the 4.25. If you plug it in, it becomes 0, dude. Do you see it? That's why you should not be including with the bar 4.25. So anyway, it's 0 here. So I mean, you're going to flip it. The maximum space, right? It makes sense, of course. The maximum space for the area you can have inside the page is 8.5 times 11. Is that okay? Right. Let me flip this over. You make sense of the number, and then you can point the arrow. Dang it. So here's the y between 0, not including, and whatever that number was, I forgot, 93.5. 93.5. There it is. Now, you may want to put the units, if your teacher is going to be critical, the units like put on the side here, inches. There you go. Now, as you can see what happened, if I put the actual value 4.25 into the area, it gave you 0. It makes no sense. That's why you should not include the bars. However, online, on the computer, in the Alex system, they bracket it. It makes no sense. Yeah. Sophia got that a problem similar to this, but it's a volume problem. So this is where I can actually demonstrate to her why it doesn't make sense. But she's more like a robot. She'll accept it for the grade. But then I have to show it to her. Then she'll be persuaded that this is the right way. Okay, let me ask you, Louis, do you understand it okay?
Yeah.
You sure? Your teacher should have gone over a similar problem on the board. Could you tell me? Could you tell me if he or she did go over this problem, similar problem on the board? What do you see in a moment?
Before, like not recently.
That looks like this. Like, what do you mean before? Do you mean like last year? Or do you mean, yeah? What do you mean before?
No, like a few weeks ago.
Okay, so she did, right? Yeah, she might use interval notation here. Okay, I'm just writing what it's like standard.
Yeah,
it's up to you.
Yeah.
Okay, now let's do C. Find the area of the printed page with the border width of 1.2, and 1.5 inches. Easy, just plug them in. I mean, I can let you do this. Use a calculator. So here's the first, you can use a calculator. Here's the first one. Here's the second one. A, you plug it in, but I'll show you the substitution here. Minus 2 times 1. 2 times 1, double parentheses, whatever. You can bracket times 11 minus 2 times 1. Close parentheses. You can punch that in. Yeah, you know what? I don't recommend you FOIL this. It's easier if you don't. I mean, okay, the other one's 1.2. Same thing. 8.5 minus 2 times 1.2. You can bracket this if you want, okay? In math. Not in programming. It's not in coding. You got to parenthesize everything. The minus 1.2. Close parenthesis. You understand this, okay? Use the calculator here. Same thing for the last one. Okay. Let me see. Then I'll graph this here. Yeah, I'll graph it in the calculator. Even graphing, right? It will look like this. I mean, you punch in the factored form. Okay, so let me graph it. You okay so far? Let me see what it looks like.
Yeah.
Yeah, it's just a parabola, dude. So here, let's see the graph. Let me make this bigger. Yeah, it looks good. 8.5 minus 2x. 11 minus 2x. graph. Yeah, here's the parabola. And let me see what you can make of it. Yeah, so you want to look at the graph. But when you graph it, though, you may want to, I mean, you can graph the whole thing, but, you know, when you want to graph it within the range and domain of this thing. Let's see how you make sense of this. Check if I punch this in correctly. Yeah, that's right. Now, obviously, the bottom portion here, if you ever use a number, for example, greater than, look, this is perfect, like I was describing to you earlier. If you use a number like 5 for the x, it's negative. Look at it. See, look at the graph. See, like 4, between 4 and 5. See that? It's the y, or the area, it's negative. There you go. You can see it. Now, you don't want to use anything greater than that. You don't even have to look at the rest of it. For the graph, you want to see what it looks like. Let me see it. Let's see the intercepts. I mean, you can grab the whole thing and you can shade it. Let me try to do something like that. So I grab the whole thing like looks like this, but you cannot accept all the graph. You cannot accept the whole graph. You only accept the portion of the graph here. Or let me show you what I'm talking about here. So we're gonna do it 4.25. So it's a little bit, and then let me see the intercepts here. See, the intercept is 9 point. Look at the y-intercept, 93.5. So that's how far you can go. So therefore, if you want to show what you want to keep, will be something like this. This is like a little portion of the graph. Here it is. So you want to see what that looks like. It'll be from 0 to 4.25 here. It's up to you, okay? But I think your teacher may mark you. Hey, you can't graph me the whole thing. It's only this portion of the curve right here that's valid. You see that? From 0, it doesn't go through, okay? From 0 to 4.25, or the y value from 0 to 93.5. 93.5. So Lewis, my belief is that your teacher will only accept this part of the graph right here. Don't go down on the bottom there, okay? Don't go down on the bottom there. It's only like this here only. Don't go into negative. Oops. But I still recommend you kind of like sketch all of it and then kind of dash this or something, dash this other portion here, dash this here or something. I don't know. But the only graph is this little curvy part right here. Okay. And that's it.